der Industrie Podcast des VDMA. Did you know that machines talk to each other? Of course, not like we do, but machines and companies are constantly exchanging data, and it is of course important that they ideally understand each other. Otherwise, it gets complicated, just like in real life. And that's exactly why OPC UA was developed. OPC UA stands for Open Platform Communications Unified Architecture, and it is set to become the global production language in mechanical and plant engineering. In today's VDMA Industry Podcast, we talk about how far this language has come, the hurdles it faces, and the opportunities it offers. And my guests are Michael Wittmann, president of Wittmann Group. The Wittmann Group is a manufacturer of injection molding machines, robots, automation systems, and auxiliary equipment with 10 production facilities in 6 countries on 3 continents. And Wittmann already uses OPC UA. Stefan Hoppe, the OPC Foundation president, coordinating the OPC expansion into new markets and the Internet of Things, Industry 4.0 and cloud solutions like digital twins and data spaces. And Thorsten Kühmann, managing director of VDMA Plastics and Rubber Machinery. A very warm welcome. Nice to have you with us.
Thank you.
Thank you. Hello.
My name is Steffi Burmeister, and I'm looking forward to an exciting new podcast episode. How did machines communicate before the global production language existed, Mr. Kuehmann?
Well, actually, they didn't communicate at all. And still, there are some machines out there not communicating. But, the benefits of communications are very obvious. And it is clear that in an intermediate step now, we have to adapt communication to machines. And the problem is that manufacturers teach languages to machines, but they are different. So when it comes to the factory owner, then he has machines with a lot of languages. And the first step is he has to teach them to have one language. And for that reason, it makes a lot of sense to have one standardized language. And that language is OPC UA.
Yeah, but how did you develop this language in the first place? Does someone sit down and think up vocabulary and meanings?
Yeah, in a certain way, that's true. But it's like with a real language. It's not only one person developing that language. There are many involved. In our case, those who build certain machines as competitors are always engaged. And they must come to an agreement. We have already made one important decision in mechanical engineering as a whole, and that is to adapt to OPC UA. And that is kind of a grammar for the language. But of course, a language will only work if you've got the grammar and the word. Applied to machine technology, this means we have to agree on how the interfaces between different machines and components must be designed. For example, in OPC UA specification 40077, we have defined an interface between the injection molding machine and MES. This means that the injection molding machines can now talk to MES across manufacturers and, for example, exchange information about part quality, temperatures, or active job settings.
Why was OPC UA chosen of all things? Were there other options?
Well, OPC UA was chosen because it fulfills all requirements of the industry. The production language should be open. That means not tied to a manufacturer's or a platform. Number 2, it should be very secure, so data will not be lost. And it should be able to model data structures for machines. And with all this, we're on the safe side with OPC UA. And that's why the industry has clearly chosen OPC UA.
And what other advantages does OPC UA offer machine and plant manufacturers, Mr. Hoppe?
Yeah, maybe I can jump in here. Because there is a misunderstanding often on the market that OPC UA is a protocol, and this allows machines to talk with each other horizontally, but also vertical into cloud. And that's honestly not true. OPC UA is much more than just a protocol. At the end, it's just 3 bullet points. Number one, it's a very rich modeling language where you can exactly describe the thing, the machine and its behavior. Number two, transport mechanisms are built in automatically in different scenarios for the field, TCP, UDP, but also for cloud scenarios, MQTT and REST interface and so on. But most important, I believe, it's built-in security by design. And that's, in a digitalized world, I believe, the key. Agreeing what Thorsten mentioned already on the semantic, that people really know what does this variable mean across all suppliers, but having security built in the today's connected world and with cyber attacks is critically important. And we are proud that OPC UA has been reviewed by the German BSI twice, meanwhile also from the France security government, ANSI, and the OPC Foundation is also in close contact with FBI Homeland Security, and they also did presentations and so on. So that's really a key. But beside all the other topics, that it's an IEC standard and a local standard in other regions in the world, in China, Korea, Singapore, and it's open source and so on. Yeah, we mentioned that already. And what I try to do always is it's an industry standard delivering what the industry wants, and that's why stability is a critical important topic. OPC UA has been designed within just 3 years, 2003 to 2006. And since that day, it has never broken backward compatibility. This is what industry needs, trust. And that's what I'm really proud on to represent. Yeah.
Mr. Wittmann?
And maybe I can add something from my side as a machine manufacturer. What is important for us is to minimize the number of protocols we have to implement. And we were very glad actually to see that VDMA has selected OPC UA as the standard here for the protocols. Because in the past, we had a variety of communication protocols for either internal communication purposes as well as the communication with devices and machines from other manufacturers. And the effort for us in implementing and maintaining each one of these protocols and communication protocols is just enormous. Because it's not just enough to implement the protocol according to the specification. It also requires very extensive tests, and preferably with the actual remote device of the other manufacturer. And only this really ensures the functionality across different operating states. And no matter how detailed and precise the specification is, there's always a certain amount of room for interpretation during the implementation. And this makes reliable and stable communication over a long period of time very difficult. So in this respect, it is for us as a manufacturer, it is our wish to have to develop as few communication protocols as possible, but to use them as often as possible. And this is where exactly OPC UA as a global communication standard comes in very handy.
And where exactly do you use OPC UA so far?
Now, there are different kind of applications for OPC UA. We have it in our control system internally for the communication, for example, between our control system for the visualization and for the control system of the real-time part of our machines, for our robots and our peripheral devices. We also use communication, also the OPC UA communication protocol between different devices from our own product range and portfolio. For example, for the communication between our injection molding machine and temperature control unit, or injection molding machine and parametric blender, for example, or dryers and so on. But it's also used actually for the communication between auxiliary equipments by themselves, such as a temperature controller, for example, with an intelligent flow control. But we even go beyond our own machines, of course. I mean, this is the nature of this protocol. We use OPC UA for the communication of the injection molding machine to an MES system, or a complete Wittmann work cell to an MES MES system. Another example would be, for example, here, injection molding machine to a dosing pump of an LSI application. And this definitely shows, so these examples really show you the wide range of possible applications for OPC UA. And once again, actually, as I mentioned already before, actually, is the advantage is that the same communication technology can be used for different kind of devices. Yeah, injection molding machine, peripheral equipment, or auxiliary equipment. Yeah, to an MES system, and the development cost is therefore significantly less than having to implement a variety of different protocols for the different types of machines and equipment.
But what I like to highlight here is, right now, you mentioned all the use cases for, I call it interoperability inside the OT world. So everything inside the factory, between machines, between components, from components and the machine to SCADA to MES. I just like to highlight that there are two significant more areas where OPC UA is scaling to. It is scaling from the OT world to IT applications and cloud applications. And there is no need for you to extend your existing solution. You can extend it with an update, but this update allows to run OPC UA over MQTT to a lot of cloud applications, like the applications from Alibaba Cloud, AWS, IBM, Google, Microsoft, SAP. And you don't have to spend extra time to design another cloud protocol to move data standardized into their applications. And I believe this is becoming critically important because we will have in the future a lot of artificial intelligence offerings, and they need standardized information. And we should not, and then I'm glad we avoided to have multiple protocols to multiple cloud companies. Because they are so strong in their ecosystem, they always say you have to deliver what is our internal standard. But because all the manufacturers came together in the energy process factory world, we are such a strong community that we convinced the IT cloud companies this is the kind of USB connector to access standardized data. Yeah. This is just what I like to extend.
Yeah, and this is exactly also an advantage for us. I mean, we see that OPC UA is future-proof. It does offer actually additional features for the future, even if we don't use them today. We're not using them today because there's a certain hesitation of end customers to connect machines to the cloud, I have to really say. Yeah, possibly in the future, this will be less of an obstacle to this kind of application, but certainly this is also possible. What I would like to mention is about the OPC UA, where we see also an advantage is just that the protocol itself is not as fast moving as web standards, yeah, which are driven by the big players, like, for example, Facebook or Google, and are constantly being adapted and further developed for new generations of smartphones because it's the main application for it and not industrial devices and industrial equipment. Yeah, and the OPC UA Foundation is looking for a sustainable standard that also takes into account the long service and support life of an injection molding machine, which goes beyond 20 years, 30 years. I believe this is quite an important feature because our customers are coming back in 10 years, 15 years, and even 20 years actually, and they still want to add actually some future, some options to their equipment. And it is quite important that there is still actually support here on this kind of communication protocols.
So you both mentioned a lot of advantages using OPC UA, but are there any hurdles right at the moment for companies and also maybe for end customers?
No, I don't think that there are hurdles, actually. I mean, I didn't mention all the advantages because we did select OPC UA, as I mentioned before, because it's really a world standard, and it is not the job of a machine manufacturer to implement as many communication protocols as possible. I mean, this is something that is extra effort. There are quite some difficulties actually implementing it properly, and we just are looking for a protocol which offers us actually a lot of advantages, like, for example, to be independent of the platform. We are using Windows and we're using Linux at the same time in our control systems. OPC UA is supported, and there are development kits for Windows, Linux, and even other operating systems which we are not using from different kind of vendors. I believe this is quite important to have this kind of open market here for development kits. OPC UA also offers you the advantages of not only exchanging here data, read and write data, but also actually allows you to call up functions on the remote machine. And this is really important actually. This means actually functions would mean that it's called in OPC UA, it's called methods. This means that code can be executed directly on the remote station. And this allows the event-based operation of a controller, which is particularly actually important for remote and distributed systems, which either a machine can be nowadays, but also a network, and even goes beyond the network to other suppliers, actually to machines from other suppliers. So there is really a lot of advantages actually in regards to scaling it up from a single small device actually to a big machines, to a work cell actually, and even to a factory. And that is important for us.
I'd like to extend here a little bit. And Michael, you mentioned exactly toolkits. And I believe that's really the key for rapid adoption. I mean, when I started and provided the world first OPC UA server about 18 years ago, there has not been really toolkits and there has been not open source offerings. This is all available today. And I have been fascinated visiting a different other group about laboratory analyzer devices. So OPC UA is growing into other businesses. I can talk about that later. And here, this group, the laboratory analyzer devices, are organizing so-called hackathons per year, 3-4 hackathons. And people come, they bought a toolkit or they go with open source. And then the first day, they just implement and load the standardized information model into their server. On the second day, they do the implementation to their own physical asset. And so after 2-3 days, they have a first server up and running. And this is hiding a lot of the complexity. It is different than 30 years before, where you really implemented a protocol, starting with a header and adding content and calculating a checksum. It's no longer like that. It is really modeling the data, and the rest is provided in a toolkit or in the open source solution. And that makes it really easy. Yeah.
So just a lot of advantages and no hurdles. Everything is running smoothly.
I would say the more manufacturers are using OPC UA, the better it is. I don't see, and we don't see as a company here, any kind of technical hurdles actually for this. It is certainly a question about acceptance, and especially about worldwide acceptance. As I mentioned before, for us it would be important to have as few protocols as possible, because to make them reliable, to make them really here stable is not an easy task. We would like to see as a manufacturer, our wish would be to have actually just one protocol, and we believe that OPC UA is offering all the technical features to do it, but also actually it shows actually a very good acceptance in the market, on the market. And so we believe actually it could be that one protocol which in the past nobody else has achieved. And why has nobody else achieved it? Because it's independent of manufacturers. In the past, all the protocols were somehow linked to some manufacturer. And of course, there's resistance and there's opposition from the competition to this one manufacturer who has implemented a protocol, and certainly they will not accept it. I don't see this problem here with OPC UA.
Michael, your wish will become reality. Because remember, years ago, we implemented applications reading data from one device, converting the data and sending it down to another device. And with OPC UA, meanwhile, two OPC UA-enabled devices can directly talk with each other, machine to machine. I believe this is exactly critical important, because in a production line, you have machines with different ecosystems from a field bus, but they are now able to talk horizontally direct to each other. But to extend a little bit where OPC UA is also growing, and this is really exciting, I haven't mentioned that before. Just a few days ago, we received the wish from the vending industry for coffee and snack machines to integrate OPC UA also. And this is a huge market, obviously. So OPC UA is even growing out of the factory and process and energy world into different other industries. And that's a really positive signal to the future. Yeah.
So, Michael and Stefan, the only hurdle I really see is just the mindset, because we're just about reaching the tipping point of OPC UA. It's only a question of time now that the whole industry will really use and see the benefits of OPC UA. And that's all we really have to do. Talk about the benefits, and that's what we are doing right now. So that is really the only hurdle I see. Otherwise, technology-wise, this is really the way we have to go and we can go.
I agree what you mentioned on technically there is no hurdle, there's no limitation. I agree on that. I believe the biggest hurdle is us human beings on our wish. This standard is not designed by me, and that's why we loved to do it again. So we human beings are the biggest hurdle in the perception of something. That's what I see. Yeah.
Can you tell how many manufacturers already use OPC UA?
If this was a question for me, I don't know exactly, because I got a lot of questions. How much is OPC UA adopted in the world, also in other verticals? And we can't really say that in absolute numbers. There are analysts publishing reports every year. And so we just follow them and trust them. But the reason for this is OPC UA is an open technology. Nobody, if you want to implement this or integrate it or use it, you do not have to be a paying member of the OPC Foundation. And you also do not have to register your product with the OPC Foundation. It's really free of charge, usable. There are no runtime fees to the OPC Foundation, nothing. And that makes us, it makes us impossible to really figure out the numbers. But looking to the news, who is announcing to support OPC UA, where you see it in industries, that's tremendous. And right now, end users are making a lot of pressure. If you read success stories from Equinor, the largest oil and gas company in Norway, or Renault in France, or Miele in Germany, and multiple others, or Procter & Gamble made a success story. So they are contacting their suppliers. Specifically, Miele did that and says, you have exactly 1.5 years time, and then we want you to deliver OPC UA, otherwise you are out. And because I don't know if maybe it's because it's still a family-owned business at Miele, and they are in good, trustful relationship with suppliers. They managed that 100% of suppliers delivered OPC UA, and they so you have to read their success story. They even decided to change an existing factory line. And change that back to OPC UA, which normally you never change a running machine, right? But they did, because they have been so much convinced on higher security in these days, to be aware, protected against cyber crime attacks, but also have more efficiency, and they save money. So that was their key status information. But all of that information are public. Yeah.
So if I, as a machine manufacturer, decide that I want to use OPC UA, what are the first steps? What do I do?
The first step actually would be, as we have done it, to purchase here the development kits for OPC UA, and to implement the communication protocol actually together with the development kit, which is definitely minimizing the efforts behind it. Yeah. And we have done this many years ago. We are using it now for many years, this protocol, and with very good success. And I have to really say, because more and more companies are now jumping on this protocol, actually for us it's a big advantage. Another one would be, which is really important, is the testing of the protocol. And the VDMA, I have to really say, together with the Euromap efforts, helping us here quite a big deal because they are also organizing here events where different kind of manufacturers are getting together. And you can make the testing here within the industry at a scale which is otherwise actually impossible if you would do it actually on an individual basis. I would say Euromap definitely actually has taken on a big role in supporting OPC UA as the protocol for the industry. Another advantage or another feature of OPC UA that we can see is that developers are liking to use it. They like it to use it because reading documentation and dealing with every single bit is not necessarily one of their main occupations. And with OPC UA, it is possible that the server already provides documentation. That means actually that also facilitates the development of the code, and it helps definitely actually here to shorten the development time. As I mentioned before, it's not our job to really develop as many protocols as before, and I can only mention it over and over again. We want to have a stable protocol with as many manufacturers as possible here to minimize our efforts. I believe this is an economic advantage and this is quite something that should not be underestimated.
So what's next for OPC UA? Is there a permanent development as with other languages, or is OPC UA finished at some point?
There's still a lot to come for OPC because we have a very, very good starting point. But it's about connecting to the whole global community. And we have set up already a couple of working groups on OPC UA. They work together on a very close loop, and we trust each other. That's very important. And those groups really develop OPC UA further. So we have many interfaces still to come. And I'm really very thrilled looking at OPC UA and the developments to come. Stefan, maybe you can add on this.
Thorsten, you are touching the semantic and the adoption in the industry, and I fully agree this will continue growing. But also from the OPC Foundation side, we are carefully extending it without breaking backward compatibility. I have to mention that again and again. But what I see is that OPC UA started to deliver interoperability in the OT world. Then I touched that already. We grow up to connect the OT world to the IT world with OPC UA over MQTT, adopted by 6 big cloud suppliers. But OPC UA is also growing to provide interoperability inside IT environment, where maybe a lot of the IT people have not thought about till now. But OPC UA has been a standard developed by OT and IT experts. And for example, topics like a digital twin or European regulations like the digital product passport, the product carbon footprint report, the digital battery passport. These are topics which we are touching right now. And so for companies like here Wittmann, they don't have to spend additional own research money to cover these European regulations. Instead, just load, for example, a battery passport into the OPC UA server or product carbon footprint. And then this OPC UA server is running in edge or cloud scenarios. We have shown that already 2 years ago, and we are extending this. And this makes it really easy and adaptable and stable also to access these regulated data, what machine builders have to provide in edge and cloud scenarios without any additional other standard. Yeah.
OPC UA is the global production language that has been developed so that machines and systems around the world can exchange data with each other without any problems. And about all the opportunities and advantages for companies we were talking today in this Industry Podcast. Many thanks to my guests, Michael Wittmann, President of Wittmann Group.
Thank you much.
Stefan Hoppe, the OPC Foundation President.
Thanks for having me.
And Thorsten Kühmann, Managing Director of VDMA Plastics and Rubber Machinery.
Thank you.
And if you, as a company, are interested in OPC UA, then please contact the VDMA. You can find more information at vdma.org. And if you like, you can also subscribe to the VDMA's Industry Podcast. You can listen to us on Spotify, Apple Podcast, Google Podcast and Podigy. Der Industrie-Podcast des VDMA.